Hello world, welcome back to another DownUnderCTF 2022 write-up video. In this video, we'll be walking through the forensics challenge, Lost in Memory. Let's get into it. Looks like one of our emu soldiers ran something on an outpost machine and now it's doing strange things. We took a memory dump as a precaution. Can you tell us what's going on? And the rest of this challenge prompt just tells us how to submit it and what the questions we need to answer are. And we'll worry about that in a little bit here. Let's draw our attention over to my PowerShell terminal over here where I have the memory dump for our challenge downloaded. It's this emu outpost.raw file. The first thing we're going to do is run image info on it to get the profile for our memory dump, which is essentially the operating system that it was taken from. So we'll do /volatility, TAC F, and we'll pass in our .raw file, and then we'll run image info. We can see our suggested profiles right here. So we're going to test out the first profile and see if it works properly for us. We're going to do TAC profile and then paste in our profile. And then we're going to run PS list for testing purposes. And you can see we successfully get a process list back, which means our profile is more or less the correct one. So what do we do next? Well, we're going to run the consoles module, which is going to give us a bunch of command line history. And we're going to pull this back over here because we're going to use this command line history to answer our first question. Our first question is, what was the name of the malicious executable? And they give us an example of what it would look like. And if we scroll up in here, we'll actually find that a monkey.doc.ps1 was executed. Now, I don't know about you, but that seems pretty suspicious. So that's going to be our answer for question 1. We'll go ahead and start typing out the flag down here. So let's maximize this again, and we can see under this monkey.ps1 execution entry here that there were 2 jobs ran, and we can see what looks to be a PowerShell command executed within these commands. So how do we go about looking at that full command and what it could be? Well, we can actually dump this process from memory into a data file, and then we can run strings on it to parse out all the readable ASCII in there, and then we can go and search for that PowerShell commandlet. So we're going to use volatility to achieve this. We're going to do our standard volatility command right here. And then instead of consoles, we're going to specify memdump. And then we're going to pass in the process ID, which I believe was 1136. And then we're going to specify an output directory of some sort. But we probably need to actually make that output directory. So let's go ahead and do that and then rerun it. And if we print out the contents of our out directory, we can see that we successfully have a dump file here. So let's go ahead and run strings on that dump file. And we'll also go ahead and specify a minimum string length of 10. That way we can get any very small negligible strings out of the picture. And we'll redirect that into a 1136.txt file. Okay, now that that's finished, we're going to minimize our PowerShell window and we're going to pull up our challenge directory here, and we're going to right click, edit with Notepad++ on our 1136.txt output file, and then we're going to actually want to pull back up the console history here. That way we can actually know what we're trying to search for inside the file. And we're looking for IEX new TAC object. Okay, so we'll pull back up our Notepad++ file. We'll do a Control F for new TAC object. And we can find these script blocks down here. And if we scroll to the right, we can see that there's a weird file being pulled from some kind of IP address from a non-secure HTTP link. So that is definitely suspicious. We see a commandlet here that says invoke reflective PE injection. That doesn't seem like it's good. And then we have emu.dll, and if we keep scrolling, we see kiwi.dll, which are definitely non-standard Windows DLL libraries. So this is very suspicious. And this also happens to answer our second question, which is, what was the name of the PowerShell module used? We can quite clearly see that the PowerShell module is called invoke reflective PE injection. So that will be our next answer. Now it's asking what were the names of the two files executed from the malicious executable in alphabetical order with dash in between and no spaces. And we just stated what those files were. They're the emu.dll and the kiwi.dll over here. So we will type those in as our answer to question number 3. Now we need to look for the password of the new account created through PowerShell. And the way I did this was, well, we know that this account was created through PowerShell. So why don't we do a Control F for PowerShell? Now you're going to get a lot of hits back, but don't fret because the one we're looking for is very obvious and you'll be able to see it very easily. So we'll maximize the screen here so we can see it easier, and I'll drag this up a little bit. And we're just going to scroll down until we see an extremely long line of PowerShell code. And we'll see it right here. Whenever you see these random variable names, it's a good indication that there's some kind of malware being run. So we're actually going to copy this out, and we're going to paste it into our PowerShell terminal here. Now, don't run it yet because it is going to try to create a user on your system called admin, and you'll be able to see what this actually is saying here in a second. If you notice this dot right here, that's what's executing this line of code right here. So we don't need that dot, and we're going to simply throw in a write tac host right here so we can actually see what's being done to our system in a printable format rather than have it actually execute on our system. And as you can see, it kind of reorganized our variable here. And we can see net user admin. So admin is the new user being created, and we can see the password being set right next to it. And all it says is super secure. So we can copy that, and we'll go to our flag submission here, and we'll paste that in, and we'll clean it up. And we'll put our closing curly brace. Now this should be our flag. And we'll go through everything one more time just to summarize all the answers. So first question was, what was the name of the malicious executable? We found that out by running the consoles module in volatility and then looking at the command history. The second question was, what was the name of the PowerShell module used? And we found that out because we saw part of the commands being called in the jobs, and then we dumped that part of memory out into a file, ran strings on it to pull all the readable ASCII out so that we could then find where those were being called, and then we found them. And then we found that there was a call out to some kind of download server or whatever online, and it was essentially running two malicious DLLs through this invoke reflective PE injection commandlet. And then number 3 was, what were the names of the two files executed from the malicious executable? And that would be emu.dll and kiwi.dll. You could find those simply in the same commandlet line that we saw in the file where the invoke reflective PE injection commandlet was. And then our last question, question 4, was what was the password of the new account created through PowerShell? And all we had to do was scroll further down in our process memory dump. And we found it by just Control Fing for PowerShell and looking for something suspicious as we were scrolling down. Luckily, there weren't that many entries that we had to look through, and it was very obvious which one it was. Then we just took our PowerShell code and modified it a bit so that it wouldn't just execute, because if you did execute it, it would actually create an admin user on your own system. And yes, it does work. I already tested it out. And we just printed out the actual command that it was running, and we saw the password, which was super secure, being set along with the admin user and the local group that it was being assigned to, which was administrators. So that was this challenge in a nutshell. So we'll go ahead and submit that. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.